Unlock the secrets of efficient Python debugging to maintain code quality and enhance your productivity. Learn to identify and resolve common issues using advanced debugging tools.
Welcome to our deep dive into mastering Python debugging. Debugging efficiently isn't just about fixing errors, it's about enhancing your coding productivity and maintaining high code quality. In this video, we'll explore essential techniques every Python developer needs to know. Whether you're dealing with syntax errors or complex logical bugs, these skills are indispensable. Stick around, and by the end, you'll have a toolkit to tackle Python issues like a pro. Don't forget to like, share, and comment on your most challenging debugging experiences. Let's start with the basics. What is debugging? At its core, debugging is the process of identifying and resolving errors in your code. These errors can be syntax errors, which occur when the code violates the rules of the Python language, runtime errors, which happen during the execution of the code, or logical errors, where the code runs but produces incorrect results. Understanding these errors is crucial because they directly impact the functionality and reliability of your application. A good debugging workflow involves writing tests to catch errors early, using tools like linters to catch syntax mistakes, and employing systematic approaches to isolate and fix issues.
Print statements are the simplest form of debugging. They allow you to output variable values and execution flow directly to the console. While they can be incredibly useful for quick checks, they have drawbacks, such as cluttering your code and not being suitable for more complex debugging. Use print statements sparingly and remove them after debugging. Alternatives include using logging instead of print, which gives you more control over output levels and formats. Enhance your print debugging by using formatted strings to make outputs clearer and more informative. Python's built-in debugger, PDB, is a powerful tool for stepping through code execution. To start using PDB, you can set breakpoints with import PDB, pdb.set_trace in your code. Once the code execution halts at a breakpoint, you can navigate through your code line by line, inspect variable values, and execute arbitrary Python commands. This allows for a deeper understanding of how your code operates and where it might be going wrong. Mastering PDB can significantly reduce the time spent on debugging complex issues.
Advanced IDEs like PyCharm, VS Code, and others provide robust debugging tools that go beyond what PDB offers. These IDEs allow you to set breakpoints visually, step through your code, watch variable changes in real time, and analyze the call stack to understand the sequence of function calls. You can also set conditional breakpoints that trigger only when certain conditions are met, allowing you to zero in on specific issues without stepping through every line of code. Using these tools effectively can transform your debugging process, making it faster and more efficient.
Even seasoned developers fall into common debugging pitfalls. One major mistake is over-relying on print statements instead of using more sophisticated tools. Another is ignoring error messages, which often contain valuable information about the nature and location of an error. Not using version control can make it difficult to track changes and understand how a bug was introduced. Lastly, failing to reproduce a bug before attempting to fix it can lead to wasted time and effort. Always ensure you can replicate the issue consistently and understand the context in which it occurs.
Debugging issues in third-party libraries can be challenging because you may not be familiar with their internal workings. Start by reading the library's documentation and reviewing examples that demonstrate its intended usage. If you encounter unexpected behavior, examine the library's source code to understand what might be going wrong. You can also use the library's issue tracker to see if others have experienced similar problems. If you identify a bug, report it to the maintainers with a clear description and, if possible, a reproducible example. This collaborative approach helps improve the library for everyone.
Automation can significantly streamline the debugging process. By writing Python scripts to automatically test your code, you can catch bugs early and ensure consistent behavior across different environments. Automated error reporting tools can alert you to issues as soon as they occur, complete with stack traces and context. Integrating these scripts into C/CD pipelines ensures that all code changes are tested before deployment, reducing the risk of introducing bugs into production. Tools like PyTest and Unidist are excellent starting points for test automation. To become proficient in debugging, adopt strategies that streamline your workflow. Collaborate with peers when tackling particularly challenging issues, as fresh perspectives can uncover solutions more quickly. Document your debugging process and findings, which can serve as a valuable reference for future issues. Commit to continuous learning by staying updated with the latest debugging tools and techniques. Lastly, keep your code and debugging tools organized to minimize confusion and errors. These practices not only help you debug more effectively but also foster a professional development environment. We've covered a comprehensive range of techniques to help you master Python debugging. From understanding the basics to leveraging advanced IDE tools, each method plays a crucial role in efficient debugging. Keep practicing these techniques to solidify your skills, and don't hesitate to explore new tools and strategies as they emerge. We invite you to share your thoughts and experiences in the comments below. Your feedback helps us shape future content. Stay tuned for our next video, where we'll dive deeper into Python development strategies.